All right. We're live for day 7 of Advent Code 2025, starting in 45 minutes. So, as usual, we've been going through 2015 problems for warm up and cool down, hoping to get to 25 by the time we get to day 12 this year. So, we're on 15. Let's take a look at this. Today you set out on the task of perfecting your milk dunking cookie recipe. All you have to do is find the right balance of ingredients. Your recipe leaves room for exactly 100 teaspoons of ingredients. Okay, make your list of the remaining ingredients you could use to finish the recipe and their properties per teaspoon. All right. Ice Cold Witch, hello. Alka, thank you in advance. Day 7 is often the day I choke. It's usually because I have a drink beforehand. But we'll see about this year. All right. So we're making cookies. We have 100 teaspoons of ingredients, and we have ingredients with all of these properties. Let me make that a little bit bigger. You can only measure ingredients in whole teaspoon amounts accurately, and you have to be accurate so you can reproduce your results in the future. So the total score of a cookie can be found by adding up each of the properties and then multiplying together everything except calories. Okay. So if we have these ingredients, if we use 44 of butterscotch and 56 of cinnamon, we need to add those properties and then multiply. So do calories not come into play anywhere? Add up each of the properties, then you multiply everything together. When you say multiply everything, okay, so the full capacity, and we multiply all those four. Ignoring calories for now. So if any properties have produced a negative total, it would have instead become 0, causing the whole score to multiply to 0. Okay, so we have to maximize this. This feels like a linear algebra problem or a brute force search. I mean, how many possible combinations are there? Let's look at our input. Okay, I mean, we only have 4 ingredients. I mean, we can do the combinatorics on this. So how many ways to split that into 4 groups? You basically can have your bars be... So you would look at like your 100 teaspoons, place bars in between, and then just all the fertile permutations of that is your number of ways to split. That's a lot. So we're looking at greater than 100 factorial, like 104 factorial. Right? Yeah. Okay. So we can't brute force this. Can we avoid doing algebra by doing a search, like a binary search kind of a thing? We have 4 boundaries. I say we can just start by modeling the problem, and then we can mess around with it a little bit in the worksheet to see what it's like. And then we can decide if we need to put it into a matrix of some sort and do real math, or if we can do it programmatically. So we'll go to day 14, so I could copy that, 14 of 2015. Alrighty. This was definitely a late night problem. This was the one last night where ANS2 was just a 4 lines code. But I went on a big old detour building a state machine. 3 a.m. code, that is. Okay. So, ingredients. Okay, we have capacity, durability, flavor, texture. We don't have to give these actual names, right? This can be a tuple. It can be a list. But I want to do it this way. All right. And so if we measure a score, so what's the score of some combination of the 4 ingredients? I guess a recipe is each of the 4 ingredients multiplied by some amount. So let's score a recipe. Def score. What am I doing here? Score. So we only have, we only have our 4 ingredient possibilities. So we'll just give that in. So give sprinkles, butterscotch, uh, chocolate, and candy. And this gives us another int. I suppose this recipe could be a map of each of those to, could also be a case class. I don't know. There are many ways to model this. And probably the best way to model these is I'll just list some numbers. But let's at least get our ingredients. So, val ingredients, ingredients was input.collect. So we have some name. I'm just going to copy one of these strings and use that as a template. Okay, so there's a name. There's a capacity C, durability D, flavor F, texture T, and calories C. No, we have a second. We already have a cal. We'll just call it cal. Uh, so C dot to int. Let's make this vertical. Durability. D dot to int. We have flavor. F dot to int. Texture. See, this is the kind of place where I should use Copilot. Calories. Cal.2it. Um, all right. So that's our ingredient list. I think I just want to give them their actual names. So how do we do this? We're gonna make this, we can match. So this equals ingredients. Great. Um, this gives us a name clash, actually. Eesh. Let's just abbreviate those. Okay, so to score something, we give it, we add up all the properties of all of these. Let's double check that. Right, so each of those properties gets its multiplier. This is like a very thinly veiled. Is this a matrix multiplication? I would have to draw this out. This is just a matrix multiplication, isn't it? I should just make this a 2D vector. And you know what? I need to visualize this. So let's do that real quick. Where's my pen? All right. Okay, so we have 4 ingredient amounts. We have 4 ingredients, each with 4 different properties. So I'm going to list those here vertically, right? And maybe those are supposed to be columns. I don't know. It's been a while since I've done this. We could at least. Okay, so there's just 4 amounts. So, N1, N2, N3, N4. And then the final thing is, so this, we scale everything here by N1. I think this should actually be vertical, shouldn't it? So we scale that vector by this. Oh, and we get its sum. Maybe this isn't a matrix. So multiply it by those 4 and then get its sum. Here we multiply it by those 4 and get its sum. And then the final thing is all of those multiplied at the end. Product. Okay. I think my life will be easier if I do just use lists. So let's backtrack a little bit. We can keep that case class. Maybe we might like for something else. Okay, so val ingredients. So input dot collect. We'll make it a vector. So this is going to be a vector of int. And each of those vectors is like the stats of a particular ingredient. So we still match it kind of in the same way. We're going to ignore name, but we're going to take those 4 properties and put them into a vector. So c.toInt, d.toInt, f.toInt, and texture.toInt. And we don't use calories yet, but let's just put it in there anyway, because we'll have to play with it eventually. So a score, we have amounts. So amounts is a vector of int, and we could represent this with a tuple, but the vector will give us easier library methods to work with. But we do want to verify things, so we're going to require. I'm just going to assert. So assert that amounts.size is equal to 5, right? No, 4, because there are 4 different ingredients. And then assert amounts.sum is equal to 100. Those are our conditions. Okay. So we take each of our ingredients. We're going to zip the amounts for the ingredients. Amounts.zip ingredients. And for each of these, we can scale it. So case some n amount, and then properties. So we're going to get the properties dot map with multiply. So multiply, scale it by that amount. And then we add them all together, dot sum. And then after that, we take the product of everything, dot product. Okay, so we can score something like score, you know what? I think just to make my life easier, I want this to be a repeating argument of ints. Yeah. So let's say we had 25, 25, 25, 25, right? Okay, that's the score in that case. Great, let's just play around with that a little bit. So let's, I don't know, let's drop this. Let's increase this. Okay. Now if we look at our ingredients, or let's look at this formula. What matters most? When you scale something, its elements become part of a sum. So it's basically that sum just gets scaled up and down, right? So we could take, for every ingredient, take the sum of each of those. Okay, and now we can scale each of those individually, and then it's the product of those that we're trying to maximize. And to maximize a product, it has to be as equivalent as possible, right? So we want to scale whatever is the lowest currently. right? Yeah, anytime you're trying to maximize the product, you want them as equal as possible. So like in this case, we can kind of just sort of finagle some of the math. Um, there's going to be 4 times as much of this as there is of this, right? For example, say we had 60, 15, 15, and what's left after that? 10? I mean, that wouldn't be quite right because it needs to be larger than the others, but it's going to be closer to the answer, no? Oh, it's further from the answer, actually. I just want to test out my theory a little bit more. Um, Hold up a sec. No, 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 no. To maximize a product, we should just be maximizing, we should just be dumping everything into the 12. Because every one we add into the 12 adds like another by 12 we're multiplying, right? Yeah, if we're all just like adding +1 plus or -1 to each of these, then we would want them to all be equal. But some of these scale faster than the others. So what if we had I don't know, 1, 1, 1, 97. Just maximize one of those 12s. Then we have an integer overflow, I'm pretty sure. So let's convert all the ints to longs in here. Int replaced with long. And we don't care about those. Okay, I mean, that's legitimately, that is legitimately low. Okay, what if you had 49, 49? Just maximize at 2 12s, right? 49, 49. Okay, that's higher than that. Okay, so this isn't a min-max approach then. Someone watching knows math, and if you do, I'd like to know the math behind this too. I have some Wikipedia reading to do after this. Okay, let's backtrack to this sort of idea then. So let's say the first one really is 4 times the last two. I don't know. Let's do 40, 10, 10 at the end. And that leaves 40 for the first. So what's the effect of increasing one of these? Oh, well, let me fix that. That was a lovely pose. Okay, nice and fixed. Thank you, Tarek. Tarek Kick. I've been misreading your name. Okay. I'm not, you know what? So far, just splitting them equal has been what's optimized it. Let's just divert from that a little bit, right? Let's make the 12s 26. They're our largest sides of our hypercube. I don't want to believe that it's just splitting it 25, 25, 25, 25. Right? This is what we would get. So for each of these ingredients, you do end up summing each of them, right? You sum them after scaling. So this is as if we scaled them all by 1. Then we take the product of that. If we scaled just one of those by 2, oh wait. If we scale just one of those by 2, it doesn't matter. It's because we're taking the product of it, right? If we multiply 12 by 2, it's like and then we're taking, it doesn't matter which one we multiply by 2. Except it does matter. I'm missing some math here. You just calculate all possible. You can brute force that? I guess you could. Um, yeah, you know what? My 100 factorial figure earlier was a bit off. You're right. This is like 100 to the 4th power. So this is 100 million possibilities. That's very brute forcible. You're right. You're right. Let's do that. So for a from 1 to 100, well, could it be 0? Do you have to use each ingredient? Okay, so 0 until 100. B from, no, 0 to 100. To 100. B from 0 to 100 minus A. C from 0 to 100 minus A minus B. And D from 0 to 100 minus A minus B minus C. Yield score. Well, these are all the possibilities. We're going to get max by score because I want to see what it is. So val combinations. We're just going to yield A, B, C, D. Proportions. We'll call it proportions. So val, let's just do proportions dot max by score. Let's make this a list. Score of that proportion. So wait, how do we put? It changed the syntax in Scala 3 for doing var arg things. Let me see. Scala 3 var arg. Yeah, you just put star on it. And score takes var args. I suppose these need to be longs. That's what's going on. Okay, let's let that run. We had an assertion fail. Oh, wait. We need them to add up to 100. So D is actually fixed. So D equals 100L minus A minus B minus C. Wrench, hello? I appreciate the paperclip. Do any of you watch Louis Rossman? An Eternal Lord, hello. Okay, yeah, it is 25, 25, 25, 25. Um, I'm just still trying to wrap my head around why that's the max. Oh, wait, I know why it's max. I can explain it right now. So, the numbers that you're adding here, you're basically just multiplying by those four proportions. So 3 times 5 times 12 times 12 times those four numbers. And as I was saying at the start, if you equalize, right, if you have a square and side lengths are like 1 to 10, 1 to 20, they have to add up to 10, then 5 by 5 is going to be 25, right? 6 by 4 is 24. So splitting it evenly, yeah, I was skirting around that for too long. This is the answer. Val and 1 is that. There's no need to search the maths. I was just failing to math. So we've had it. We've had the answer the whole time. Alex, hello. Welcome. Okay. So 843750000. I feel like sometimes I can code on stream, but mathing on stream is, oh wait, answer's too high. What? 84375. I mean, that was that answer. Um, hmm, hmm, okay. If any properties had produced a negative total, it would have instead become 0. Oh, wait. There's an extra rule in here. Negative totals become 0. Aha. So our score method is wrong. Okay, so okay, so this is the properties of that ingredient. So wait, which total? 44. So we have to get the properties of the cookie we're baking, and then we multiply those together. What we're doing here is different. So this is the properties of each ingredient. I think it ends up sort of being the same thing, but we need to transpose the ingredients. Well, okay, we still scale each of these. So each of these properties we do scale for that ingredient, right? And then we sum each of the properties across those ingredients. Yeah, negatives as 0. And here, well, what I'm doing right now is doubting that I did this correctly. Right? This is the properties of a particular ingredient. So you do have to scale those. So that's right. But we shouldn't be summing across the right. This is us summing like capacity with durability with flavor. So that's wrong. So we scale everything, right? So now we have a list of scaled properties. And then what we have to do is we have to transpose. So instead of being, so I could I could give these names. So Val, scaled in scaled properties or scaled ingredients, right? So we'll just call it scaled so that you can follow what I'm doing here. I just realized we had a mistake. So um, if we transpose these scaled, then we get it by all the individual properties, right? So scaled dot transpose. Now each of these is the properties in order. So each of these needs to be summed across the full categories. So dot sum, and these are the cookie properties. So I'm gonna call that props. And then the score is those props multiplied. So props dot product. Wait, transpose dot map sum. Okay, and what the rule says is that if any prop is negative, it becomes zero. Negative totals become zeros. So we're just going to filter. We can map. So dot map case n less than zero. N if n is less than zero, then zero, and then any other n's just go to n. Okay. R27, that's a familiar name. You are not filtered today. 450055. Okay, so we take the score of that. Wait, this is a list. So Val, so we just take the score of those properties, or proportions rather. Props means both properties and proportions. And that's our answer. 133249536. Okay, so the math I was blabbing on about earlier was wrong because this was wrong. I didn't do the transpose and then some. That's still too high. Oh, wait, I didn't finish entering it. Wait, it said it was too high? It said it was too high, right? Highest scoring cookie you can make. The total might be positive even if one is negative. Yes. um, yeah, I'd imagine so, right? All we're doing is any property scale. So we take the sum of all the scaled properties, right? And if it's less than zero, then we get zero. Otherwise, we keep it. Is the score method correct? I think I should just test my score method on one of the examples. Let's use the example ingredients and try a score. So do this. Vector. It looks correct to you? Good. I'm glad you agree. Right? But then why is this part wrong? I mean, for one, I didn't even enter my full input, but I'm pretty sure it said that the input that I did enter was too high, right? Yeah, still too high. I have to wait 1 minute. We can do 1 minute. So that's too high. Okay, let's do a test with the ingredients from the example. So butterscotch, -1, -2, 6, 3, 8. And here we have 2, 3, -2. Oh, the calories. The calories. We are considering the calories. That's the problem. Okay. So amounts of ingredients, we scale all the properties. I think we should just do properties dot init, leave off the calories. Yeah, leave off the calories. We are not counting calories. There we go. That looks much better. 2, 2, 1, 3, 6, 7, 3, 6, 8. There it is. Okay, the recipe is popular. Somebody asked if you make another recipe that has exactly 500 calories per cookie, so they can use it as a meal replacement. Keep the rest of your award-winning process in the same scoring system, but it needs to be 500 calories. Okay, more constraints. Hmm. Okay, we keep the same scoring method. We don't need that. Proportions. So proportions now have a limit. We could just throw on another filter. So proportions.filter 500 calories. So def um, yeah, calories, I don't know, calories 500. So we have our proportions. Um, we'll do it the same way. So now we just take this, well, this is a Boolean. Okay, oh my God, we don't have much time left. We can do this very quickly. Amounts, I have an alarm set. Okay, so we're just gonna take amounts.zip with the last of the ingredients. No, ingredients.transpose.last. Ingredients.transpose.last. We're not gonna have time. We'll have to do that afterwards. Okay, let's go. Hofstadter, we've got a Scala fan. Welcome, welcome. Good luck. Good luck, Ice Cold Witch. You're doing Janet this year. I've not heard of Janet. Um, day 6, 2025. We're gonna save that as day 7. We've got 1 minute to go. I'm glad we did a warm up because it got the I think it got the stupid out of my system. Maybe I'll read this problem properly. All right. See you later. Come back and join the leaderboard when you have a minute. All right. Good luck, everyone. Day 7, here we go. Laboratories. So we help the cephalopods. Familiar halls. This is a reference today to past years. I'm going to take a look at that later. Of a North Pole research wing. Based on the large sign that says teleporter hub, they seem to be researching teleportation. Okay. We try out the pad. We are in an unfamiliar room. It's leaking magic smoke. Um, Lots of spare parts, manuals, yada yada. After connecting tools, it displays errors. There's a issue with tachyon manifolds. We locate a diagram of the manifolds, which is our puzzle input. So tachyon beam enters the manifold at the start and moves downwards, and then there are beam splitters. Okay. However, this sounds familiar. If a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam continues to the left and right. Okay, makes sense. Um, is this a tree? A Christmas tree? Looks very piney. Oh, it splits and keeps going in those directions. I see. It doesn't turn left and right. Okay. To repair the teleporter, you first need to understand the beam splitting properties. Would split a total of 21 times. How many times will the beam be split? Okay. So we have a starting position, and I suppose we can fold left across these rows. And for each row, um, yeah, at each row we just track the positions of the beams. So starting with just one beam position, and then we look for these symbols to split, and then we need counts of the splits. Honestly, what we could do is just have them duplicated, so the number of beams is related to our number of splits. So if we have 2 beams, it's because there's 1 split. If we have 1, 2, 3, 4, yeah, every split creates 1 more beam, right? So the number of beams minus 1 is our answer. You got this. We're gonna import. No, we don't need to import. We can just get the position of S. So val start equals input dot head dot index of string S. Okay, and input dot tail dot fold left. So we have a list of our positions, and that will be start. And then we have a line. So in the line, we look at beam positions. So, wait, case, what do we have? We have our beams. So splitter locations, val splitters equals line dot all indexes find. There should be a method for finding index where, all index where, last index of. I guess we could zip with index and filter. Okay, so we'll do line dot zip with index. Um, and this is going to be a collect. Collect. So case, there is a character and there's an index. Um, and that character in particular that we're worried about is the beam splitter. And if we see it, we return that index. So those are splitter indices. Um, and then now we're going to flat map our beam. So beams flat map. So we have a beam, and if beam is in the splitters, then we split it into two more. We're gonna make this a set, not two set. So if splitters dot contains B, then we have a list of B minus one and B plus one, two new beams. Else, now my worry here is that it might split so many times. Well, I mean, we could look at the input. Yeah, I'm not too worried. Never mind. We don't need to keep counts or be smart or anything like that. We can just have duplicates in the list. Otherwise, we just have a list of the original beam. Great. So val final beams is equal to that. And ans one is, so every beam means there was a splitter, so we just subtract one, right? So val final beams, oh wait, nope, ans one equals final beams dot size minus one. And it's totally gonna work the first time. I feel it in my bones. Hello? Oh boy, that's taking longer than I thought it would. I guess we don't need to find all the indices of all the splitters. We can just check in the line and see if we've hit. Okay. Okay. Let's comment that out. So if splitters at B is equal to that, or no, if line at B is a splitter, then we split. Otherwise, it's just a B. That's much more efficient. Okay. We shouldn't be using lists here. We should be using vectors. But, oh boy, that's taking too long. It's still taking too long. Let's change that to vector. And then maybe we get smarter and start using like map counts or something like that. And if we must, maybe we do something beautiful. And just keep updating a map or something. Geez, how big is our input? Our input's not that big, so I don't imagine it's an issue. I don't imagine it's like a performance issue. I think maybe there's an issue with my algorithm. No way. Okay, let's look at our input size. So input dot size, and let's just count all the splitters in there. Wait, it's struggling just to run this. No, no, no. There's something. Is it still trying to evaluate an old version of the worksheet? Let's look at our output here. Yeah, it's compiling. Well, I'm just gonna restart VS Code. But I mean, I think that's it. We could kill all JVMs. Oh, yes. Welcome, Eric. I don't think the input is that big. All I tried to do most recently was look at the size of the input, and VS Code pooped out. Right? I can just look at the input. Um, yeah, that's not that big. I don't think anything needs to be optimized. Input that size, and then we're gonna just count all the beams. Honestly, counting the beams is enough. Counting the beam splitters is enough. So input dot map map. So for each line, we count every character that's equal to that, and then we do dot sum. So that's the number of splitters. Each splitter, not every splitter is necessarily used, but I do want to know how many of those there are. Don't forget how to install this stream last time you were here too. Oh, yeah. Was that when you were here? Yeah, I think I had a problem where I had it solved just a couple days ago, and then stalled for another 5 minutes before actually putting in. I love it when it works, but man, I need to be the one writing bug reports on on worksheets and asking about the performance issues because I'm not imagining this, am I? Like this happens pretty frequently. Eric Wassel is a menace. You get cursed at least 100 times every night. Wait, not found in the yes, because it has to rebuild the project. Am I even able to compile the project? So I'm just gonna try to compile the project. Okay. We're dropping the worksheet, going to VS Code, or going to SPT. That's your Avenue code cover band. Makes sense. At least you own it. All right, let's look at this code again. Um, for each of our beams, if it's hitting a splitter on that line, then we do B minus 1 and B plus 1. Otherwise, we just keep that B. And then the number of beams minus 1 is the number of splits. So, hey, we are live. We are live. Okay. It's a tiny file. There can't be more than 1,600 of these. So we can handle this. We can handle this input. They have been fun this year. Yeah, I appreciate it. That's about the same as me. I'd be curious to know too. Um, okay, is this running? Did it compute? 2019, Inco 2019. Yeah, that's that's easy to claim as a favorite. Hmm. I think my answer to that question would depend on when you asked it. It's probably easier to answer like favorite from each year. Even then, there are like some good contenders each year for like the best of that year. Okay, so did we thread interrupted? Um, I don't know. Do we have like JVM threads going on in the background? Okay, we're finally evaluating. We're evaluating it twice. Why do we have two evaluators running? I think I just need to kill the JVM. Yeah, those are taking too long anyway. Kill all -9 job. Um, I can think about why it might not be performant. Like I am taking a lot of like really tiny vectors, uh, and flat mapping them. So I'm like growing this very slowly and doing it by making new vectors. But I'm making at most 2000, which is why I'm not worried about the performance implications of that. Mhm. Right, I suppose I could make this an iterator, iterate over each of them, and then um, and then build it back into a vector for the next iteration. I don't feel like that should be necessary. Otherwise, I could just drop into some sort of mutation and um, drop values into a list. Again, at least in this example, a lot of these lasers are actually overlapping. So we could do, you can do accounts map. Uh, you like to figure out this weird program in a weird language is doing. Yeah, I've liked all of the interpreter problems. Okay. Um, okay, we've got to do something more performant. We're gonna do accounts array. So that thing is one. We gotta comment that out. And let's comment this out too. Or we'll do counts map. Mhm. So val counts equals collection dot mutable dot map for a column. So this is int. Okay, so we're taking input dot tail. So we're going to do for line and input. I do like today's. I'd like to see part 2 of today's. Okay, so we do still have our same start, right? So we can seed this map with start to 1. So the beams that are splitting, I suppose it only matters is only every other line gonna contain. Let me check that. Well, we can do that optimization later. So we are going to look at all of our beams. This way we're not splitting, multiple beams multiple times. We just double account. So beams for B and count. So the beam itself, index and count in counts. And let's filter out the zeros because we don't want to do math for zeros. If C is not equal to 0, we should do that this way. So for the index in C and the count in counts, if C is not equal to 0, do. So if I is, let's see, line at I is a splitter, then we change that count. So we take, oh, hold up. If we do this with mutation, we run the risk of affecting other counts. So we do still kind of need to map it. So we're just gonna get the new counts. So this is gonna be a yield. Geez, I suck with mutation. We still want to decrement the count at those particular indices. So first, why don't we just get all the indices that are splitting? So val splitting equals all the beams and counts. So counts dot filter case I C. And for each of those, if line I equals a splitter. Okay, so here are the beams that are splitting. Now, for each of those beams, we're gonna decrement the count. And then for each of those, I think this I'm gonna make a defensive copy because we're dealing with mutation. Okay, so for each of those, we're gonna decrement the count at the index, and then we're gonna increment the counts at either side. So for I see in splitting, do counts at I minus equals C. And then counts at I plus 1 plus equals C. And counts at I minus 1 plus equals C. And of course, we're going to filter 0 counts out of here. So case I see if C is not equal to 0. All right. How is that looking? We add it twice, we subtract it. And then now to compute our answer, just take all the values of the counts. Oh wait, this map does need to have a default value. So let's give it a default value with default value of 0. That way we can still do plus equals when there's nothing been seen there yet. Okay. And then it's all the counts. Counts dot values dot sum minus 1. That's our answer. I suppose this doesn't need to be assigned to a val. Okay, we did have an issue here. Let's see what it was. Match error, 70, 0. Oh, right. So if I guess if C does equal 0, we just move on. It's just gonna be false by default. That could be part of this condition, I suppose. We could move this into here. So we could say C is not equal to 0 and that. But in any case, this should give us an answer. I do the same thing, plus I'll watch multiple streams. Okay, so we got an answer. 352321813. I think if we want to avoid the mutation, it would be as simple as using a map instead of a vector of all the counts. Oh, that is not the right answer. Oh, you know what? I suppose multiple beams can be being split by the same one. So the fact that there are only this many splitters doesn't mean that's like a hard limit on the number of beams at the end. Part two is your favorite part this year so far. Cool. Yeah, I think we have our first problem where it's ramping up. It is the first weekend of Advent Code. Okay, I have to look at why this is wrong. So, I mean, assuming that the final counts are actually correct, is this the right formula? Every split that happens to a beam creates one more beam. So if we start with one beam and end with like 1,000 beams, then there were 999 splits. So it has to be that minus one, yes? Okay, let's try this with the example and see if you get the same answer. A07 dot text 2025. Okay, we're gonna save this as an example. I can feel my computer lagging out a little bit, so if you notice the stream quality go down, please do let me know. In the meantime, we are going to try this with the example. I guess it really was a performance issue. I don't know why I didn't want to believe that. So we'll give that a second to run. Well, I mean, if I'm being honest, it is a combination of issues because it should take no time to evaluate this. Thread stop evaluating. Yeah, so it's ceased evaluating. Hmm. I'm just going to take a peek at H top while this is running. Let's restart the build server. Okay, all cores are running on something. VS Code, is it Java? Is there some Java thread running? You wonder how much extra electricity you used up in today's puzzle. Ah, any cheap FPGA hardware. My notifications have stopped again. I said I would fix that, but Ola Ola Weed and Boys. Hey Stu. I hope your weekend is going well. Should someone first learn Java, JVM, or can you just jump into learning Scala? You can totally just jump into learning Scala. There's plenty of people who've like gone out of their way to make it accessible. And in a way, it is a lot simpler. So like you could say with Scala, there's like a higher ceiling. You could make things a lot more complex, but you can make the simple things very simple too. And Scala as a language, its specification is actually a lot smaller than most other big languages because it's more generalized, right? There are fewer like special cases in the language. All the weird stuff you see is people building on top of the baseline generalized stuff. I can't think of resources right at the moment. There's a book by Li Hao Yi that I would recommend. It's like a free ebook, Hands-on Scala. That's where I'd start if you wanted to learn. Thread death. Mm, okay, so I'm looking at HTOP. We still have all threads running. I think I just have to kill all. Maybe I should kill WSL altogether. Hands-on Scala, exactly. Oh, well, there goes my performance issues. All right. So now we just now we just restart um, VS Code and hope we don't run into that again. Because the code we're running here is fine, right? It's the commented out stuff we don't want to run. And this is running on the example input, so it should not have any performance issues. Okay, we validate the worksheet in 5 seconds. Things are still warming up. Well, let's see the output. It still seems to be doing things. Importing build, indexing. I don't know why it needs to do all that. We could talk about how I would rewrite this. So this would be a map from start to 0 or start to 1, and with a default value of 0. With default value of 0, right? Um, and we would still take the beams, but now when you flat map it, it's a beam with a count. So this is going to be like beam and count, then minus C and plus C, except we're updating a map. So what we'd actually do is something like beams.updated b minus 1 with a new value beams b minus 1 plus plus the count. And then we'd also update it for the one that had b plus 1. Right? That's how we could do it purely functional. But also, okay, the worksheet is still not running this. I think I might have to change to running this just in SBT and not relying on the worksheet. So we're going to do just that. Here on the left side, we're going to change this to a normal Scala file. Take me just a minute. Alrighty. So we don't need this. We do need a package. 2025 and at main def day 7. Will I vanish from Twitch once admin of code is over? What is your favorite anime question from the previous stream? I don't know. Okay, there are a few good ones. I could name things I enjoyed. Rerun was good. Attack on Titan was good. I wouldn't say it's like a favorite, but it's something everyone's watched, right? History suggests yes. Well, this year, Advent Code is only 12 days, so I will be here for day 13. And the plan is to do the Cinecore challenge. So, at least in that sense, I will be here after Advent Code. And maybe that will be the momentum to carry on into January, you know? Okay, we just print our ends one, and we're gonna run this in the console. We gotta delete all this stuff. Okay. Let's fire up SBT. Oh, look, it's running now. Okay, so for example, we got 39. That's not what we want to get. So there's something wrong with the reasoning. So let's look at this. We have start goes to 1. Let me catch up with chat for a second. You've got to say, Cinecore is the most fun I've ever had programming. I thought it was so thought-provoking. I'm excited for it. I'm excited. And I think, Zuno, you're the one that said that and commented that in my Reddit post, brought it back to my attention. So I appreciate that. I'll have a lot of fun with it. Okay, yeah, this ended up being 39. So if we look at our code. So our idea is to start with 1, a count of 1 for start, right? And on every line that comes in, we keep track of how many beams we have at each index. And if any of those hits up with a beam splitter, then we are going to split it. And we split it by removing, I guess, we're setting this equal to 0. So we're removing all those beams from our current index because that's being split. And then we're adding those beams to the adjacent indices. Yeah. And honestly, so in this case, we'd start with 7. Let's print each of these splits. So we can see what's happening and trace along. Splitting at I. Splitting how many beams? C beams at I. Okay, let's let that run. It looks like our worksheets are back to normal. So this is good. So we split 1 beam at 7. Then we split 1 beam at 6 and 1 beam at 8. Then we split 1 beam at 5 two beams at 7, one beam at 9. It's kind of like a Pascal's triangle thing going on. One beam at 4, three beams at 6, one beam at 10. Wait a second. One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There are 22 beam splitters, but not all of them hit. Only 21 of the beam splitters hit. Oh, okay. Right. So if two beams hit this, we don't want to double count that. We just want the number of basically we just want the number of beam splitters that did their job. That's what the problem is asking. Okay, okay. So we're gonna take all the count values and then we're gonna count how many of them are greater than 0. And the number of beams at the end isn't gonna be the same as the number of splits, is it? The number of distinct beams? No, it's not. So let's just count the splits. We'll count the splits explicitly. We're probably solving part 2 before solving part 1. You're talking about how the company has fallen apart. Yeah, I saw it briefly a few years ago. Okay, let's count this. Var splits equals 0. We're starting at 0. So for every split, splits plus equals 1. We're trying to be too clever. And then val adds 1 equals, oh, we need to hoist this var splits up here. Okay, so for the example, that should just be 21. Really straightforward. Nothing clever. I'm trying to be way too clever. Now you run that for the main code 1504. This problem isn't that hard. It's really not that hard. All right, we got it. 48 minutes in. I choke day 7 every year. It's always because I have that birthday drink before Advent code. Okay, so part 2. I'm gonna scroll to the bottom. How many different timelines would a single tachyon particle end up on? And that's the first thing I was doing. So counts.values.sum. This is ans 2. We already solved it. We are overthinking it. Solving part 2 before part 1. Not the first time that's happened. So we've already seen the answer. So 3, 5, 2, 3, 2, 1, 8, 1, 4. Wait, do we still have to do -1? This, so in the original, the particle ends up on 40 different timelines. Right, if we look at our example, let's make sure. That should be 40. Yeah, 40. So when we do that with the real problem, are we having like integer overflow? 3, 5, 2, 3, 2, 1, 8, 1, 4. Yeah, I'm supposed to have a great delta. I'm trying to push it. Um, but this is wrong. Um, I think it just needs to be longs. I'm just gonna replace all the ints with longs. Okay. And add an L there, add an L there. Wait, start. Oh, start does have to be an int. That's an index. Okay. There it is. There it is. 5137133207830. Had a great delta. Oh my god. Oh yeah, good job, Michael PC Gamer. You beat me to it today. The back off timing didn't nail me. So we're fine. There's no setting in Scala to throw on overflow underflow. Um there's no setting, but what you could do, like you could do your code generically for any integral type. So instead of int or long, you can just do it for some type n, and then you can choose your type at the end. So that works. Michael PC Gamer, I appreciate the raid. I hope you had a good stream. But thank you, everyone. Yeah, it's pretty easy to just do find and replace int to long when it happens. Okay, okay. This code is horrid. I want to stop looking at it. I think I need to redeem myself. We're gonna finish day 15. I was like 30 seconds away from solving it when the problem dropped. So let's do that. Did I do depth first search for both parts? Nope, nope. I just did a pass through and did counts. Counts to the left and right. Um, wasn't that hard, just fighting my computer. Okay. Day 15 of 2015. So we were baking cookies. And now we have an additional constraint. So these cookies have all these properties, right? And then there's a method for getting the score. And then all the ingredients, you have to get them in proportions adding up to 100, right? And then doing that, you have to find what's the maximum score given in some number of proportions. So we did that for part one. Now part two has an extra constraint, and it's that we only have 500 calories. So we're going to throw that in just as a filter. So to do that, we take the calories in the ingredients. So val cals. And for each amount, we multiply. So amounts.zip with the calories. We multiply that across. And then we get the sum. And that is the calories. And we check if it's equal to 500. And if it's equal to 500, we pass. Let's just say calories is our function. So, and 2 then is going to be proportions not filter calories of that said proportion is equal to 500. And then After that, we do max by, or, map score. Um, you have to do this little thing. And then dot max. And that's how close we were to solving this problem when day 7 dropped. Eric Wassel uses Perl. Cool fun fact. Oh, yeah. I'm just going to do this as a single collect. Collect. So case props. This is proportions. We're going to call this amounts. Just p's. So p's, if calories, p star is equal to 500, then we get the score of those p's, and then we get the max. Okay, there it is. That reads better, doesn't it? Yeah, that's much better. So we let that run. It is evaluated, but it's not showing me the evaluation. Is there an error in here? There's no error in the file. I mean, I suppose I could just paste this into a console and that would run. I don't know. The worksheets are just giving me trouble today. Missing parameter type. Oh, there is an error. Missing parameter type here. Zip cals. So longs and longs. Zip. Why can't we just do that? Oh, wait, we have to map. There we go. And we required int. Let's make that long. Okay, yep, there it is. There it is. 1766400. Cool. Now we got time for one more. Let's take a peek at 16. If it's a fun one, let's do it. So, your Aunt Sue has given you wonderful gifts, and you'd like to send her a thank you card. She signed it from Aunt Sue. You have 500 aunts named Sue. Oh no. So to avoid sending a card to the wrong person, you need to figure out which Aunt Sue. Ah, hey, okay, this does seem interesting. Um, so you open the present, and as luck would have it, good old Aunt Sue got the first My Crime Scene Analysis machine. Just what he wanted. um, MFC SAM. That's not a great name. A great acronym. Okay. Can detect a few specific compounds in a given sample, as well as how many distinct kinds of compounds there are. So, children, cats, dogs, goldfish, yada yada. Okay. In fact, maybe your aunts have many of these. You put the wrapping from the gift. it becomes inquisitively, it beeps inquisitively at you a few times and then prints out a message on a ticker tape. So this is what we know about our aunt. Make a list of the things you can remember about each aunt. Things missing from your list aren't zero, you simply don't remember that value. Okay, so I have info about aunts, but not all of it. All right, and then we have to use this to narrow that down. Okay, so I guess we just filter each of those against our specifications. I don't think we even need to really make any models or anything. So input.collect. Let's take a look at an input string. Here we go. We use that as a template. So Sue, there's the number. Oh, we're gonna have to parse this differently. So we're gonna take the rest of it and split on commas. Or I don't know, stats. Okay, stats.split on commas, and then collect. So now we're going to further split these strings. So each of these is a trait. I guess we're going to call these traits. So there's a trait, colon, and account. We can make this n here ID. So it's the ID of the Sue. And this n here is the count. All right. What's going on here? Anyway, we have trait to n. Oh wait, we can't use the word trait. What text does this use? Many of these. These are the things you can remember about each Atsu. So we're just gonna call these things. There we go. Here's a thing. And we give that tuple and dot to. Okay, so now that we have all of these, we want our what do we call this? Our crime scene data. This is our forensics. Val forensics equals. So we're gonna multi-line cursor this and turn this into a list of tuples, which I guess we can wrap into a map. Yeah. Okay. So now that we have our aunts, aunts, we're going to filter on them. So aunts.filter. And basically every trait about the aunt should match forensics. We can just do another collect. No, let's filter. So case, there's an ID, and there is things. So if you want aunts where things dot or all for all case thing and count. Then forensics for that thing matches the count. And then we'll call this matches. And matches should be just one. So we'll look at the size. Prometheus, thank you for the follow. Overall is not a member of any. Wait, what is things here? Aunts.filter. Aunts is a list of arrays. Wait, need to. A list of arrays of IDs. Okay, so this ID actually needs to go out further. Into int. Oh, right. I think we'd wanted to take each ID. So ID to the formatted things. That's what we want. Key not found children. Right. So either matches. And if not, so we'll do forensics dot exists dot exists. No, not necessarily exists. Let's say not exists a thing that doesn't match properly. Or we can do like a get or else. So forensics dot get thing if it exists, right? And let's do match there because it's clear to write. So if there's some value, sure, then value equals n. And if it's not there, you get a pass. It's true. Okay. Matches.size should be 1. And Prometheus asks, hi, what are we doing today? I didn't know there's an advent of code. I knew about advent of cyber. Yeah, advent of code is huge. Like hundreds of thousands of people do it every year. But check out the website. This year it's only 12 problems. But we have too many matches on the aunts. Okay, let's print all of these matches for each print line. I want to see what's going on. Oh, we've got an array here. Arrays aren't printable. So let's turn something into a list. Where did we end up with an array? Things that split. Here, we'll make this a list.to list. Okay, so this aunt has 5 goldfish, 8 children. 8 children should disqualify her. And oh wait, that's space children. So we misparsed here. I think we forgot to strip things. Oh, I suppose after each comma. Yeah. So let's just strip these afterwards. Map. Yeah. Dot map dot strip. Okay, that should drop the match sizes to 1. Cool. Okay, what's the number of the suit? So matches dot head. Um, 213. Cool. Now part two. As you're about to send a thank you note, something in the machine's instructions catches your eye. Apparently, it has an outdated retro encabulator. That's a Back to the Future reference or something. And so the output from a machine isn't exact values. Some of them indicate ranges. In particular, the cat and tree readings indicate there are greater than that many due to the unpredictable nuclear decay of cat dander and tree pollen. Okay. While the Pomeranians and goldfish readings indicate that there are fewer than that many. So it's not exact in either of those. It's strictly greater or strictly less than. Okay. So we have special cases now. So we're just going to take this line, and for certain things, yeah, for certain thing values, so like cat and tree, it needs to be greater. Just copy that whole bit. You know what? Before we do that, let's do a quick refactor here. I don't want to do this matching here. We'll add a guard if forensics.contains thing. And then in all other cases, it's just true. We pass the test. Otherwise, it's just true. Okay, great. So that still works. We don't need this match. Oh, wait, we delayed something too much along the way. So forensics thing needs to match. So equals n. Okay, great. Now we can do special cases for other things. So, for example, cats. Um, we're gonna copy paste this and make this matches two because we're changing the definition. So it matches two, and we'll keep track of the size as we're editing things. All right. So in this case, matches cats. Then I'm gonna name it thing at cats. That way you don't need to change much code. Then forensics thing, it needs to be greater than n. Right, so there's already a change. All right, and I think we can match multiple possible values if we put it in rent. So cats or trees. indicates that there are greater than that many. Am I doing this right? So this says there are greater than that many. So that means the aunt, like the forensics. So for whatever the aunt stat is, the aunt stat needs to be greater than whatever forensics gave us, right? Okay, that makes sense. So for cats or trees, greater than that many. And for Pomeranians and goldfish, it needs to be less than, fewer than. So Pomeranians and goldfish. Now there are 5 possibilities. Hmm. Okay, before I try to figure out what's going on wrong here, let's just refactor this slightly. I just want to take these guards out. So let's just filter out anything. So if forensics doesn't contain the thing, then it just gets a pass from the start, right? Now, for all these other things, you don't have to do this guard. And our lines are a little bit shorter. Maybe things are a little bit more legible. Okay. All right. This reads a little bit better. But now, is it correct? Did I just misread less than and greater than? No, in this case, what happened? Unreachable case? Yeah, it's an unreachable case. Thanks for telling me. Right. Yeah, I just did them backwards. So, whoops. Ants 2 equals matches 2.head underscore 1. 323. Hey, that wasn't bad. We're getting so very close. Um, let's take a peek at 17. Oh, this is short. The L's bought too much eggnog again. You'll need to move it into smaller containers. For example, suppose you have containers. So they have 150. We have containers of these sizes. If you need to store 25 liters, there are 4 ways to do it. Oh, this is just a coin counting problem. And our puzzle input is our sizes of containers, right? Okay, this is a familiar problem. I think I've solved it in the past. Um, that's simple enough. I think that can just be my warm-up tomorrow. I think we'd rather do like an interesting one here. Take a peek ahead. Okay, some sort of grid problem, like an automaton machine. Oh, so with a few lights, he says you'll have to resort to an animation. Okay, start by setting your lights to the included initial configurations. I think that will be a fun one. But I think I might call it a night. Everyone loved 2015 day 19. Is that so? Okay, I have to take a peek. Medicine for Rudolph. Wait, is this a graph problem or is it a replacement? So molecules, and it just grows. It's a counting problem. How many distinct molecules can be created after all the ways you can do one replacement on a medicine's molecule? Okay, and puzzle input. Oh, okay. This seems familiar. This looks like the polymers problem, kind of. Okay, I'll probably do that with a map to count the ways. Okay, we'll give that a proper read through, and we can look forward to doing that tomorrow. Okay, so for tomorrow, 17 will be pretty straightforward. That's a common problem. 18 looks doable, not too tricky. 19 will be a fun one to end the night on. So we'll do our warm up with 16, get that out of the way, have some fun with 17 before the problem drops. And let's find someone to raid. Which advent of code? I think it's time to raid Alka, isn't it? It looks like Alka's still working on it, so we caught them on it. Yeah, cool. All right. Thanks for stopping by. Hmm. Okay, let's cheer Alka on. Have a good night, everyone, and we'll see you around the rest of the month. I might not disappear this year.